Usually, when you think about a national emergency, right, you picture this very, localized event.
Right, like a single point of failure.
Exactly. Like a hurricane hitting a specific coast, or, I don't know, a flood in a single river valley, or an earthquake in one city.
Yeah, the disaster zone.
Right. The cameras all point in one direction, the resources all flow to one spot, and you can just, draw this neat little circle around the problem on a map.
But that is definitely not what we're seeing right now.
Not even close.
Yeah.
If you look at the American West today, that neat little circle just completely shatters. Today, we are pulling apart the August 8th, 2026 Daily Tech Reader Wildfire Report.
Which is a fantastic resource, by the way.
Oh, it's incredible. It aggregates all the ground-level data from the National Interagency Fire Center, the National Weather Service, and just a whole host of national tracking databases. And, I mean, the picture it paints for you today it's just staggering.
It really is. I mean, it is entirely unprecedented in its geographic spread.
Yeah.
We aren't looking at a single disaster zone anymore. We're looking at this highly complex, highly interconnected crisis that is stretching across, more than a dozen states simultaneously.
And to really understand the stakes of this, you have to look at the alert system. As of today, the U.S. is sitting at what they call Preparedness Level 5.
The absolute peak.
Okay, let's unpack this. Preparedness Level 5 is the absolute highest alert level there is in the National Fire Tracking System.
Right.
I want you to think of it like a massive hospital emergency room that is running at just absolute maximum capacity.
That's a really good way to frame it.
Yeah, like every single doctor is in surgery. Every bed is full. Every ambulance is already dispatched. There is virtually zero slack in the system.
None at all.
And if you're listening to this from, I don't know, New York or Florida or Ohio, you might think, well, a fire in Oregon has nothing to do with me.
Yeah.
But Preparedness Level 5 means your local specialized crews, your regional aviation assets.
They're gone.
Exactly. They're already on a plane out west.
And that national mobilization is what makes this so critical right now. Because if we look at the animated topological map of the American West right now, the numbers are just difficult to wrap your head around.
They really are.
We are actively tracking 140 large incidents. And those fires, they're burning across more than 3.4 million acres of this sprawling, mountainous, incredibly difficult terrain.
Wow.
And to fight them, we have over 30,000 personnel deployed nationally.
I mean, 30,000 people, that's the population of a small city.
An entire city, just out there on the line.
Entirely mobilized to fight fire. And when you see a massive number like that, you really have to wonder where they're all going and, well, more importantly, why the atmosphere is fighting them every step of the way today.
Right, because the weather is not cooperating anywhere.
No. The report flags that the most dangerous weather event of the day is unfolding in the Pacific Northwest, specifically Washington and Oregon. But looking at the source here, I have to admit I'm a little confused.
Oh, how so?
Well, the report says a strong cold front is moving through the Pacific Northwest today. Shouldn't cold air be exactly what we want? I mean, doesn't a cold front mean relief?
Yeah, it's highly counterintuitive, isn't it? You hear the phrase cold front and you picture like autumn leaves, a sudden drop in temperature, maybe some heavy rain moving in to soak the ground.
Right, exactly. Like a break in the summer heat.
But what's fascinating here is the mechanics of what meteorologists actually call a dry cold front.
A dry cold front.
Right, it's not bringing precipitation.
Oh.
It is purely a violent displacement of air. So imagine a massive invisible wedge of dense, cooler air, and it's just slamming into the existing warm air that's been sitting over the region.
Okay, a wedge of air.
And because this specific system lacks moisture, often because it's, moving overland rather than pulling moisture off the ocean, it acts like a giant atmospheric bulldozer.
Oh, wow.
Yeah, it brings these aggressive, rapidly shifting winds, and it causes the relative humidity to absolutely plummet.
So it's less like a refreshing autumn breeze and more like, I don't know, a massive wind tunnel just turning on, blowing this bone-dry air over vegetation that is already totally parched from the summer heat.
That's exactly it. And the physical mechanics of it are an absolute nightmare for firefighters. When that dense air pushes through, it doesn't just, blow steadily.
It's erratic.
Very. It creates turbulent, erratic gusts. In Washington and Oregon right now, particularly in the regions east of the Cascade Mountains, they are facing an extreme risk of explosive fire growth today.
Because of the Cascades.
Yeah, the Cascades act as a wall. They strip whatever little moisture might have been left in that air. So by the time that front pushes down into the Columbia Basin and sweeps across toward the Blue Mountains, it's just a wall of dry wind.
It's pushing across millions of acres of receptive fuel.
Exactly.
Hold on, though. I'm looking at the temperature data for this front in the report. And cities like Spokane, Washington, and Pendleton, Oregon are sitting in the low 80s today.
Right, low 80s.
Honestly, 80 degrees sounds like a perfectly pleasant afternoon to me. Why is 80 degrees in the Northwest a national emergency, while we regularly see places hit 100 degrees without the whole region catching fire?
Well, temperature is only one leg of the fire behavior triangle.
Okay, what are the other two?
The other two are wind and relative humidity. You can actually have a fire burn incredibly hot and fast at, say, 40 degrees Fahrenheit if the wind is howling and the air is completely stripped of moisture.
Really? Even at 40 degrees?
Absolutely. In places like Spokane or Yakima today, the cold front is keeping the ambient temperature deceptively moderate, but the wind is actively wicking moisture out of the pine needles, the grass, the brush.
Like a dehydrator?
Precisely. When humidity drops into the single digits and you have these sustained winds pushing 20, maybe 30 miles an hour, an existing fire can easily double in size in a matter of hours.
Wow.
The heat of the air doesn't even matter when the wind is essentially force-feeding oxygen to the flames.
Which means any new spark, like a drag trailer chain on the highway or a tossed cigarette, becomes this instant, uncontainable emergency.
Within minutes, yes.
And remembering our emergency room analogy, we don't have spare firefighters sitting in the hallway waiting for a new spark.
No, everyone is already deployed.
Right. But as dangerous as that wind tunnel is in the Northwest, the weather pattern physically shifts as you move south. Because if the Northwest is a wind tunnel today, California is just a completely stagnant oven.
Oh, the contrast is incredibly stark. In the Northwest, like we said, the atmosphere is moving violently. But in California, it is trapped in place.
It's locked in.
Yeah, a massive heat dome has settled over the interior of the state.
And the raw numbers hammering interior Northern California right now are just, they're staggering. The Central Valley is forecasted to hit anywhere from 106 to 112 degrees Fahrenheit today.
It's brutal.
Just processing that for a second, 112 degrees. You have Redding near 110, Chico in the mid-100s, and even at higher elevations like Grass Valley, they're pushing the upper 90s.
And that heat just bakes the fuel.
Right. But here's where it gets really interesting. Amidst all these terrifying triple-digit numbers, the report uses a specific phrase for California that sounds, surprisingly clinical.
Which phrase is that?
It warns of poor overnight humidity recovery.
Yes. While it sounds clinical, that phrase is actually the bane of every wildland firefighter's existence.
Really? Why is that so bad?
Well, to understand the physical toll of poor humidity recovery, you have to look at the natural diurnal cycle of a wildfire. A fire breathes with the day.
It breathes.
Yeah, it peaks in the late afternoon when solar radiation is highest and the air is driest. But normally, as the sun goes down, temperatures drop. And cooler air cannot hold as much water vapor as warm air, so the relative humidity of the surrounding air naturally rises.
So the moisture in the air physically condenses as it gets colder.
Exactly. And when that ambient moisture returns to the air, the vegetation absorbs it. Plants, dead leaves, downed timber, they act like a sponge.
Okay, I can picture that.
As they soak up that microscopic dew, the fuel becomes damper, and the fire naturally loses its intensity. Firefighters refer to this as the fire laying down.
Laying down, that makes sense.
The flames shrink, the rate of spread slows to a crawl, and it gives the crews their most crucial window of the day. They use the night shift to go on the offensive.
So they use that time to actually get ahead of it.
Right. They're cutting containment lines with bulldozers and hand tools right up against the edge of the fire while it's sluggish.
But poor overnight humidity recovery implies that this natural brake system is just completely broken today. The sponge never gets wet.
That is exactly what's happening. The heat dome traps the hot air, particularly in what we call thermal belts.
Thermal belts.
Warm air rises at night, pushing the cooler air down into the valley bottoms. So if you have a fire burning on the mid-slopes of a mountain, which is very, very common in Northern California, the temperature at 2:00 a.m. might still be 85 degrees.
At 2
Yes. The air stays desperately dry. The vegetation never gets that sip of ambient moisture. It just remains critically dry kindling around the clock.
God, that is a terrifying image. A fire that never sleeps because the atmosphere simply won't allow it to. It just keeps growing relentlessly, 2047.
And think about the physical toll on those 30,000 deployed personnel.
Right.
When a fire lays down, a night shift can make incredible progress. But when a fire has poor humidity recovery, the night shift is fighting a wall of flame in the pitch dark.
That's horrifying.
It exhausts the crews. There is no reprieve. The fire footprint expands exponentially, and the physical limitations of human endurance are pushed to the absolute breaking point.
And what becomes so clear when you look at this national report is how all of these localized atmospheric nightmares, they don't just stay neatly inside their state borders.
Not at all. Weather doesn't care about borders.
Right. The wind in the Northwest, the 112-degree oven in California, they create a massive physical ripple effect. Because you look at the interior states like Idaho, Montana, Wyoming, Nevada, Utah, Colorado, they are profoundly affected by what's happening on the coast.
Absolutely.
And the biggest physical byproduct of this interconnected system, according to the source, is the smoke.
The volume of smoke generated by 3.4 million burning acres is, well, it's difficult to even comprehend. The atmospheric jet stream acts like a massive conveyor belt.
It's pulling it all inland.
Yeah, lifting the particulate matter from California and Oregon and dragging it eastward across the Mountain West and the Great Basin.
The report shows places like Lewiston, Idaho, sitting in the upper 80s, but completely choked with smoke. Missoula, Montana is in the mid-80s, just totally smoked in.
Even further south, too.
Yeah, even down into Utah and Colorado. Salt Lake City and Fort Collins are dealing with severe regional haze. And my first thought when reading that is just about air quality, like people having to stay indoors.
Which is a huge health hazard, yes.
Wow. But looking at the operational side of the report, the smoke is actually grounding the firefighting efforts, isn't it?
The aviation impact is massive. When you are fighting a mega fire, you rely heavily on helicopters dropping water and fixed-wing air tankers dropping retardant to support the ground crews.
Right, you need that air support.
But flying in wildfire smoke is not like flying through a rain cloud.
I was trying to picture the mechanics of it. Why is smoke so much worse than a storm?
Because it destroys contrast and depth perception entirely.
Oh.
In a rainstorm, you still have a horizon line, usually. But flying a helicopter into a valley filled with dense wildfire smoke is like trying to fly inside a bottle of dirty milk.
Wow. A bottle of dirty milk.
It's not just dark, there is zero horizon line. Everything is uniform, flat, gray. You can't see the mountain peaks, you can't see the power lines, and crucially, you can't spot the ground crews you're trying to protect.
So it's just too dangerous.
From a pure physics standpoint, aerial firefighting becomes mathematically impossible. So a massive fire in Oregon can generate enough smoke to ground an entire aviation fleet in Idaho, leaving the local ground crews there completely without air support.
That is an incredible logistical nightmare. An incident commander in Idaho loses their eyes in the sky because of a fire burning 3 states away.
Exactly.
And the report makes it clear that these interior states are dealing with their own massive local risks on top of the smoke. They have their own fuel problem.
They certainly do.
Even without the heavy timber mega fires of the coast, the geography of Nevada and Wyoming makes them absolute powder kegs right now.
The physical landscape of the Great Basin is dominated by what fire scientists call flashy fuels.
Flashy fuels.
Yeah, we are talking about millions of acres of cheatgrass, sagebrush, and light desert vegetation.
Flashy meaning they burn fast.
They burn with terrifying speed. With heavy timber, like a massive Douglas fir in Oregon, it takes a long time for the heat to penetrate the bark and ignite the core of the tree.
Right, it's dense.
But a blade of dry grass has a massive surface area to volume ratio. There is no core to protect. The report highlights places like Reno, Nevada, sitting in the mid-90s with hot afternoon winds.
And Casper, Wyoming is in the upper 80s, dry and breezy.
And the afternoon humidity in those places is practically non-existent. These fine, flashy fuels lose their moisture content within hours of the sun coming up.
So they become highly receptive to ignition. You essentially have millions of acres of perfectly dry tinder baking in the mid-90s heat, just waiting for a match.
Just waiting.
But, a tinderbox doesn't burn without a spark.
Yeah.
Where's the ignition coming from? Because when I look at the final geographical zone in the report, traveling south into Arizona and New Mexico, the weather pattern shifts yet again.
It's a completely different threat profile down there.
Yeah, we leave the dry wind, we leave the stagnant heat domes, and we enter the chaotic world of seasonal thunderstorms.
The mixed summer fire weather pattern of the Southwest. And from a tactical standpoint, this is the most unpredictable environment on the map today.
It sounds incredibly volatile. The report notes places like Tucson, Arizona, and St. George, Utah are hovering right around a blazing 100 degrees.
Extremely hot.
But then you look at Flagstaff, Arizona, or Santa Fe in New Mexico, and they are in the 80s, facing isolated thunderstorms. And normally you see the word thunderstorm on a wildfire report and you think, great, nature's bringing its own fire hoses.
You'd hope so.
But the report warns heavily against this. They call them dry thunderstorms, and they specifically mention the danger of thunderstorm outflow winds.
Yes. The cruel irony of these specific seasonal storms is that they provide the ignition source, but they fail to provide the relief.
Oh, man.
They bring the lightning, which is the match that sets those flashy fuels ablaze, but the physical structure of the atmosphere prevents the rain from actually reaching the ground.
Wait, so the rain evaporates in midair?
Yes, it's a meteorological phenomenon known as virga. The storm generates precipitation high up in the atmosphere, but the layers of air beneath the storm are so intensely hot and dry that the rain droplets simply vaporize before they ever touch the earth.
Okay, wait, let me puzzle through the mechanics of these outflow winds then. So the rain evaporates, right, taking all that moisture back into a gas.
Right.
But the air itself that was carrying the rain, cold air is heavy, right? So it just falls.
Exactly. It plummets.
It's like, okay, if I take a massive, heavy encyclopedia and drop it flat onto a dusty floor,
Okay, I follow.
it doesn't just hit the ground. The impact blasts a violent ring of air and dust outward across the entire room. Is that what the storm is doing to the fire?
If we connect this to the bigger picture, that analogy beautifully illustrates the physical mechanism at work. A thunderstorm is essentially a massive column of heavy, cooled air.
Okay.
When it exhausts its energy, that dense column collapses downward, rushing toward the earth. When it hits the ground, just like your encyclopedia hitting the floor, it can't go through the earth. So it violently deflects outward in a 360-degree radius. These are the outflow winds.
And if you have an active fire anywhere near that impact zone?
It creates absolute chaos. Because a fire is already generating its own localized weather, right? Pulling oxygen in at the base and pushing hot air up.
Right, the updraft.
When a thunderstorm outflow boundary slams into an active fire environment, the winds become instantaneous, highly erratic, and multi-directional.
Oh, wow.
A fire that was backing slowly down a ridge to the north can suddenly be blasted by 40-mile-an-hour gusts to the east, then the west, within a matter of minutes.
Which means the firefighters on the ground have absolutely no idea which way the fire is going to turn.
It is one of the most lethal situations a ground crew can face. Their predetermined escape routes can be completely compromised in seconds.
Because the fire is just everywhere all at once.
Exactly. The fire behavior becomes impossible to model. So in New Mexico and Arizona today, the threat isn't just the sheer heat of an Albuquerque afternoon. It's the chaotic, unpredictable wind generated by storms that aren't even dropping a drop of rain to help put the fires out.
It's a double-edged sword, where both edges are just razor sharp. You get the dry lightning strikes causing hundreds of new ignitions in the dry brush, and you get the erratic outflow winds turning those new small fires into unpredictable monsters.
And this brings the entire physical reality of preparedness level 5 into sharp focus. You have complex atmospheric threats requiring completely different tactical responses, all happening simultaneously.
Right. Let's bring this all back to you, the listener, and the sheer scale of the physical journey we just took across the map.
It's a lot to take in.
It is. We started by looking at 3.4 million acres actively burning and 30,000 personnel deployed. And what is so deeply clear from this source material is that these aren't isolated events.
They're all linked.
Whether you were dealing with the invisible atmospheric bulldozer of a dry cold front in Washington, or a relentless 112-degree oven in California where the thermal belts ensure the humidity never recovers.
Or a blanket of dirty milk smoke suffocating the Mountain West and grounding our aviation fleets.
Exactly. Or even the dry lightning blasting 360-degree outflow winds across New Mexico. It is all part of one highly interconnected, intensely stressed national ecosystem. Every time specialized resources are pushed to combat erratic wind shifts in Arizona, those are resources that physically cannot be used to cut lines in Oregon.
It's a zero-sum game right now.
So what does this all mean?
It leaves us with a critical, lingering question that goes far beyond just today's weather report. If a single day in August requires the absolute maximum commitment of our national resources.
All 30,000 of them.
Right. 30,000 firefighting personnel pulled from every corner of the country just to cope with such wildly diverse, overlapping physical extremes across half a continent. How will our national emergency infrastructure possibly cope if these intense, overlapping atmospheric extremes aren't just an anomaly, but become the baseline reality for every late summer going forward?
That is a very heavy thought to sit with because right now the National Emergency Room is completely full, the doctors are all in surgery, and there are still sparks falling in the dry grass right outside the doors. Thank you so much for joining us for this deep dive. We'll see you next time.